recording. Now, the idea for this class came about, because I think this might have been the first class that I did, and it was labeled as mad scientist or something. And at that time, I wasn't too familiar with PowerPoint and other stuff. So it was either very, like a preliminary effort type of thing. So it jogs my memory. And there is an English historian named Peter Watson, and Kevin and I have read book about his modern world. It is a very erudite historian encompassing all the fields, like from psychology to science to politics to economics. So I was rereading his book, so that gave me the idea about doing this class. And obviously, and then uh, been interested in history of science, but I think after knowing that there are two people with solid physics background, I'm a bit intimidated. I will have to up my game, so to speak, and do some more work, So, but hopefully, and as we talked earlier, that we are in a same time slot, and you could be eating cookies in person at Unison and listening to our esteemed colleague Ron Weaver about DEI. And obviously, all of you know what DEI stands for, the diversity, equality, and inclusiveness. Instead of that, you're stuck here, in your own home, listening to about me rapping on about DWEM. Okay, now, anybody knows what DWEM stands for? Okay, well, all right, I'll just go ahead. Dead white European males. And even more, even more, this is my tribute to dead white JEAM, dead white Jewish European American males, because this is, we talked about in the class that I just finished on science of race as to how the Jewish uh, native born Americans, as well as, Europeans, the exiles from Nazi Germany, have won 25% of the prizes, So anyway, so this was, should be interesting journey type of thing. And having grew up in what was former British India, I think I'm a lot more familiar with the history of Britain rather than history of United States, type of thing. So this is the rough outline, but I promise I won't stick to it, but I'm supposed to give outline. So this is the general agenda. So we'll talk about the early stage rise of scientific revolution, and then, we'll talk in general about Nobel prizes, so some fun facts as to how the gnomes in Sweden work. And then we'll talk about mostly the science-based type of thing, mostly the physics. I'll talk very little about chemistry because I just, and I used to read recreational physics, when string theory was in the vogue, but when that started falling apart, then I moved to Tampa primarily to be close to USF and crashing on genetics and biology, molecular biology classes because that wasn't taught, So and then neuroscience seems to be more exciting, so to speak. So I've been doing a lot more about this. And I think some of you may know something called the breakthrough prizes. That is like Hollywood meets science, via Silicon Valley. So that's the new venture that is given out by the Silicon Valley and European or Russian primarily billionaires. So that's something called the breakthrough prizes. Now I think I may disappointed that I'm not going to touch too much on peace and economics because I think as far as I'm concerned, peace prize is kind of very controversial and jokes type of thing. So and in science we'll just try to avoid a lot of the politics part. And so it's like and the economics is also it's like Freudian psychoanalysis, basically goes to follow Karl Popper's thing. It cannot be falsified, so to speak. So we won't get too much into it, but hopefully we'll have enough to talk about with talking about physics and something that I know about because, as most of you know, I'm a retired physician, and with no, so really I'm more into applied sciences rather than pure sciences. So I'm to catch up with my deficiencies. Okay, these are some of the administrative details. I'll send out the slides and PDF, and you'll probably have more material to keep you enough busy for next 6 months, type of thing. I already sent out one preliminary intro type of thing about a couple of interesting books. So hopefully most of you should have received it. If those of you, I think Mr. Pennington, Greg signed up later, so I'll send it out to him, type of thing. And okay, and this is a few days ago because This obviously we know that the modern era of started post-Enlightenment, but different cultures have different ways of solving problems. And just last week, NOAA had this special, on the MOA at Easter Island being moved, So you can just see that this was their way of solving problems, So this is kind of a tribute to human curiosity, creativeness, and how to solve problems, and with cooperation. So you can say 3 C's, curiosity, to know what, to quote the famous Richard Feynman, and the pleasure of finding things out, so to speak. So this is curiosity led people to get into these endeavors, okay? And then cooperation, because science is a cooperative effort, So the idea of a lone scientist going with a eureka moment, is no longer valid, because, the most recent prize for gravitational waves had 1,200 people who worked in collaboration. So we'll talk a little bit more about it as we go along. So, but this was one way of Papua New Guinea people. And again, this has been an enigma for people around the world as to why the European civilization came through a lot of the Enlightenment and other stuff, because this is a question that one of the natives of Papua New Guinea asked, the European travelers who went there, as to why your culture discovered all of this. And that's an enigma, but I don't think I have any answers as to why the Chinese did not develop all the technology that we enjoy and live with, and as to how the Europeans did. So, and obviously there are a lot of other reasons, but that does not apply to us at the present time. But, and there may be varieties of reasons depending upon your point of view. Okay, and this is, obviously those of you who know the science history would know something called the paradigm shift. And this was an old cartoon that just of interest. So I don't know if you can read the caption, but you can just see it, that this is, as to how.
Bharat, you haven't got screen sharing on.
Oh, I'm sorry. I just, thank you. Pardon me. Let me go ahead. Screen 2. Yeah, because we were chatting. Share screen. Okay, let me go back to the original slides, and then I will.
Thought it was just me.
Okay, now you can see it probably.
Yes.
Can you see it now? Okay, yeah.
Yes.
Let me go back. Yeah, let me go back to.
That makes things
Yeah.
a lot more interesting.
Okay, yeah, sorry. No, this is the outline of the screen. So yeah, thank you. Because I think, we were talking and I wanted to see the gallery. So this is, okay. Okay, so this was the outline of the screen administrative details, so you didn't miss much. Okay, so this is we talked about the MOA of Easter Island. That was the PBS special that I just talked about a few minutes ago. So I think, it's nice to have a moderator, because I think somehow, OLLI, sort of trust me more than they should, perhaps, that I don't have a moderator. So, okay, so, so thanks for keeping me on my toes, And this is the cartoon. So this is a famous word that Thomas Kuhn, who wrote about the philosophy of science, back in the 50s, and this is the word that he had used in his works called paradigm shift, as it takes because scientists, to follow, the pattern sometimes, and it takes I think somebody's mic is on probably. I think mic is maybe open, so I think, yeah, you might want to, yeah, I could hear an echo type thing. Okay, all right, yeah. Okay, so this is the paradigm shift. You can read the caption probably here, okay. All you can do is chisel all day, do something useful, help your brother. Okay, so let me just minimize this. Okay, so this was one of the ways, and obviously for science you need capital or funding, so that's what we'll talk about, how the Brits had the advantage, type of thing. And any of you who have had the so-called prep school or public school education can translate this. Okay, anyone? Okay, all right. This is what it means, on the shoulders of the giant, and the picture on the left that you can see is, in front of the Greenwich Observatory. Okay, and this sculpture has 6 astronomers featured on the monument, among them the most important in the history. Obviously, the after Enlightenment, Brits had the idea they were the inheritors of the classical civilization of the Greek culture. So one of the original one was Hipparchus, circa 125 before the current era, followed by the names that we would recognize more: Nicholas Copernicus, Galileo Galilei, Kepler, and of course Isaac Newton and John Herschel. Okay, and Albert Einstein was considered, but he didn't quite fit in the idea of being an astronomer. So this was one of the uh, uh, founders. And later on, obviously all of you know Stephen Hawking, and this was one of his later books, On the Shoulders of the Giants. And even Isaac Newton had. And so the time of this era, especially before the Royal Society around 1604, was an interesting era, because at that time a supernova appeared and was visible during the night sky as a bright shining object, for almost several months. And this may have been featured, even in the star that Shakespeare mentions in Hamlet, may have referred to it. And this may have been inspired by, well, you can just see that some of you may recall C.P. Snow's work of the two cultures of art and science. But Shakespeare was into science, so because he refers to this, and the character, and he may have been familiar with Tycho Brahe's work, and who was from Denmark, and some of the ancestors of, he obviously in those days he was a rich person, and he had a coat of arms, and the two of his ancestors were mentioned in Hamlet, type thing. So it goes back as to how Shakespeare was familiar with the current science that was going on in the continent. Okay. And I think I'm going to skip this one. I'll show this next time when we talk about, because this has to do more with more recent physics, type of thing, and otherwise we'll run out of time. Okay. And I think I'm going to have to. Okay, I'll leave the chat open on the side so I can see if anybody's comment. Okay, and now unfortunately the idea is that we have had a loss of trust, and most of these, if for those of you who are more interested, these links are clickable, and you should be able to read the whole link about loss of trust. And these are some of the slides that for whatever reasons we have. We're losing the trust in science, and you can see that fewer Americans are now saying that science had a positive effect, and you can just see how within the last 5 years we have lost, the faith in science we've dropped down at least 10% type of thing. And again, this goes along the political spectrum, okay, as to how it works. So this is one of the things that we are all well familiar with, type of thing. And this is a dramatic departure from the old days, that coming across this when John Dalton, the founder of atomic theory, when he died, 40,000 people had attended his funeral. Okay, so that's just staggering as to the science. And as we go along, some of the scientists were rock stars of that era, so to speak. Okay, obviously, they didn't have to compete with Taylor Swift, so I can understand that, that they were, they had the more of a like open field, so to speak. Okay, and again, because now the people who have done real science, people like Peter and Rex, know very well that it's not it's not like the Archimedes era that we have the eureka moment. It's hard teamwork, so to speak, and it requires funding, because this is the big restriction that comes around. So you need a mentor, either be the king himself or the government, and again, the science, the way science is done has changed dramatically. And now recently there was some data that the work that is done it's difficult to reproduce. And even the famous Dana Faber Cancer Institute recently had to retract a huge number of papers. So it's not entirely surprising that science is losing trust. Okay, so now before the Royal Society, which is our topic for today's talk, came about, there was something called the Gresham College. Gresham was one of the who is who of business in the city of London, and he had donated funds for public education, so to speak. And had sponsored a series of lecture, something called the Invisible College, and this was, and the series of lectures that he had sponsored, varieties of professorships were endowed. They did not issue any type of degree, okay, but the topics that were in vogue at that time: geometry, astronomy, and natural sciences. So these were a series of lectures that he had endowed, and even before the Royal Society, so the peoples who is who of Gresham College, that's an institution that's still around, and they still sponsor varieties of free lectures that you can access on YouTube, and these are scholarly lectures and they are not quote unquote dumbed down like TED, limited to 18 minutes. So, and one of the things would be, for those of you who have taken math, I'm sure all of you have used logarithm tables, and those were discovered by a Scotsman named Napier. And this is way before the Royal Society came into existence. And one of the professors from Gresham College, a guy named Henry Briggs, had modified the logarithm tables, and these were the predecessors of what later came to be known as slide rule. Okay, and so obviously, so they had a huge role in pure sciences, i.e. mathematics, and that Gresham College was. And then later on, varieties of other institutions. So this is the link for Gresham College, by the way. So, and you can get some interesting talks on starting from history to physics to medicine on all sorts of subject materials. So it's a delightful way to continue your learning. Okay, and later on, there is a competing association or cooperating association named Royal Institution that came about, quite later on after Royal Society, and later on, following Enlightenment, varieties of learned societies developed, not just in Britain but all over, and obviously before that was the French Scientific Society, and then later on the Geographic Society. Somewhere along the line, the Brits had aversion to chemistry, even though they were some of the founders at that time. So the Chemistry Society came in much later. Okay, so now so this was the date of founding of Royal Society, 28th, 1660, and it is still very much active, and the natural philosophers got together, and there were about 10 or 12 people of quote unquote gentlemen of means, okay, and got together and initially met into Gresham College. Later on, very quickly afterwards, they received the so-called Royal Charter, and that was the foundation of Royal Society. This was the motto: do not take anyone's word for it and trust no one. So this is a dramatic departure from just following the church doctrine. Now, the time of this was, again, those were so-called dark ages, and again, the comets had appeared. This was the age of burning witches at that time, and so, but these were the people who swam against the norm and challenged that idea of the method that was advocated by Francis Bacon in his classic tome, Novo Organum, okay, as to experimental and method that he had advocated, So that was the foundation of Royal Society. And again, these were people who carried out experiments and tried to come to the truth and finding. And they did not have any subject they did not tackle, starting from natural phenomenon to astronomy to stars to unusual occurrences, to understanding the so-called classical earth, wind, fire phenomenon. And obviously, what is may surprise you as to how much collaboration was there across the continent, because even a thing which was improved upon by Robert Boyle, one of the founders of a Royal Society, was based on the Dutch invention of Otto von Guericke, who had invented the vacuum pump, and Robert Boyle improved upon him. Now, let's talk a little bit about Robert Boyle. He was Irish, 14th child of Earl of Cork. So he was a man of independent means and had, the typical education of the upper class Brits, starting from private tutors to going to Eton College to going to Oxford and the conventional tour of Europe, to where he became familiar with Galileo's teaching, and that again inspired him to search in natural sciences himself. And and then again is the most thing that all of us may be familiar with from high school would be so-called Boyle's law, pressure and volume relationship, and based on now obviously now he did not do a lot of the experiment himself. He had an able assistant named Hook, and he did most of the experiments along with him. And with the vacuum pump, they was able to show that air is necessary for flame, and at the same time boiling water. And now again, even though he was a natural scientist, he was an alchemist at heart, and the attempts to convert metal into gold, the so-called philosopher's stones, well, unsuccessful. And so was a bit disappointed on that. But at the same time, he continued to work with search of vacuum and presented several papers and wrote varieties of books on the matter. Okay, and at the same time, he indulged in study of medicine. Okay, and now again, obviously, at that time there wasn't much given that was given for feeling of pain in animals, because obviously that this was the Descartes philosophy that animals do not have soul, so they were not above doing vivisection. And apparently he had removed the spleen inside a living dog, and the dog lived. So again, so they were proven as to how that spleen is not necessary for life. So they the animal experiments, and then so they indulge in all of the different disciplines of that time. This is one of his works, and you can see from the title that again, so they were the skeptical chemist. Okay, and again, this were talks about and his predecessor was a Swiss scientist named Paracelsus, and Paracelsus is considered the father of toxicology. Okay, and again, so Boyle questioned some of his thinking about so-called alchemy. Okay, and this is one of his many works, and he has written varieties of tomes, and so continued to be one of the founders of Royal Society. Okay, and again, as I mentioned a little while ago, the Royal Society is very much as a force to be reckoned with, starting from Isaac Newton to as recently as Elon Musk, and they've continued to make substantial contributions to natural sciences, and they hand out, and over the 400 years, there are about 8,000 fellows, and it's a very illustrious list. as many of them, 280, are Nobel laureates, and they award based on nomination alone, like they award about 60 fellowships, a majority of them restricted to UK and Commonwealth, but they do extend to some foreigners as well, So this is not, and there are some people who are honorarily invited as fellowship, and there's no field that they are exempt on, starting from computer science to mathematics to astronomy, chemistry, engineering, geology. So they have a lot bigger scope than the Nobel Committee has, because Nobel Committee is restricted based on Nobel's will. Okay, so you can just see that their scope is huge and wide. And some of you may recall from my recommendation that Bill Bryson, who is a well-known American who lives and writes in Britain, has written a lot about varieties of book. And the one book that I had sent out to you is an edited book by Bill Bryson, which is Seeing Further. So this is the varieties of people. Some scientists, mathematicians have written a book called Seeing Further: The Story of Science, Discovery, and the Genius of Royal Society. Okay, and it's a very erudite book looking from varieties of subjects. Okay, all right. So, okay, but at the same time, this is, obviously, you may have read this book as a high school requirement, Gulliver's Travels, and Gulliver's Travel was sort of satire on what the Royal Society did, as to how Gulliver meets a man extracting sun rays, okay, while visiting Royal Society. And mathematicians, were easy target, because while in US, people refer to a lot of the scientists as geek. I mean, I'd never heard the word geek until I came to United States, came to US. Okay, so this is one of the ways, and even among scientists, mathematicians are really an easy target for making fun, so to speak. And then again, so if you read all this whole series of Gulliver's Travels, it really, kind of a subtle satire, and as to how during the giant era, the Gulliver pees and puts out the fire. So it just a lot of the work that the Royal Society was doing, so it's kind of a tongue-in-cheek satire. Okay, talks about Sir Nicholas, who spends $2,000 on a microscope to see mites in cheese. Okay, and does blood transfusion to make a spaniel into a bulldog, so to speak. So this was one of the ways, it goes around. Okay, and the membership of this thing of Royal Society is really very wide, and the names that you recognize, the people, the physicists amongst you would recognize some of the names. It's like the who is who of science, basically. Okay, and all right, so we'll go ahead with some of the other members. I'm not going to recite the members. As we go along, we'll learn about a lot of the people who are part and parcel of the Royal Society. And here, so, and these are some of the subjects that they talk about, like, for I came not to bury science, but to praise it, so to quote the famous quote from Julius Caesar. Okay, and they worked on, obviously, starting from the one of the big names in Royal Society, from Isaac Newton to Faraday, who pioneered the electricity. Now, this came as a surprise to me. Champagne, okay, so we would associate champagne with France, but turns out I learned this from Bill Bryson, that a physician scientist named Christopher Merck had fermented a fizzy drink. Okay, so this was way before Dom Perignon formed champagne. Okay, then you can obviously, they can't use the word champagne, but so, and one of the interesting thing was Bayes' theorem. Those of you know math and have taken classes in math and statistics know this Bayes' theorem. And Bayes was a clergyman who said, he was, he had discovered the probability theorem called Bayes' theorem, which is widely used in all sciences, economics, computer science, and probability theory is just about everywhere in all multidiscipline. Okay, and he was so non-committal about it. He did not think much of it, did not even bother to publish it. It was one of his friends decided to send it to the Royal Society 2 years after he had died, and it was published in the publication of Royal Society, which is still around, Philosophical Transactions of the Royal Society, with the title Essay Towards Solving Problems in the Doctrine of Chances. Okay, so this was, so a lot of the work which is still very much valid. Now, the big difference that was there with Royal Society was that right from the get-go, it was international in scope. Okay, the first secretary of Royal Society was a guy named Henry Oldenburg, who was German. Okay, and as we talked about the vacuum pump, there was the Dutch. Okay, or for example, the early days of electricity, something called the Leyden jar that came from Holland. So you can just see that even as far back in the 17th century, it was an international collaboration. And even during Napoleonic wars, they continued, to communicate and travel and exchange ideas. So that was one of the biggest plus that one can say that was in their favor. And at that time, the most of the coursework that was done at the early universities, primarily Latin, was done in Latin at Oxford, Cambridge, and even the Italian universities was done in Latin. Okay, but the Royal Society's work was done in plain old English. So that was one of the biggest advantage of diffusion of knowledge that took place. Okay, and again, right from the beginning, they had sponsorship from a benevolent king. Okay. Now, the other founding member is well known to most of you, especially the Brits. Okay, at St. Paul's Cathedral, a man who was truly a polymath, so to speak, and was not just an architect and rebuilt London after the fire, but was also, in medical sciences and artist by himself. And this was some of the experiments that they had done as to how they injected a dog with mixture of opium and alcohol and had, carried out dissections. So one can just say that this was one of the earliest ways of using intravenous anesthetic. Alas, it was not further carried out, wet on humans. So, and discovery of anesthesia had to wait for several hundred years after that. Okay, and again, obviously, I'm not going to elaborate on the St. Paul's Cathedral, but that was the dome was one of the highest in the world for several years. And okay, and this is an interesting thing that they were, before the knowledge about blood groups, they were the first ones to carry out, human blood transfusion. Okay, for commoner type of things. So this was, from animal to man. Okay, so this was, carried out first in Europe, but luckily for the Royal Society, they were successful in carrying out, the first blood transfusion. So while one would associate Christopher Wren with architect par excellence, but at the same time, no, this was the so-called medical Wren. Okay, and they as well as investigated the lung function, and you can just see how expansion of chest and air. So they've been, so they were really truly polymath, as one can say. Okay, an instrument of respiration and straining from the same breath to purify will serve again. So you can just see that the physiology of respiration was defined. And obviously, this is a far cry from the modern concept of respiration, as you can see in the equation that is posted as to how energy is metabolized. But that had to wait for several hundred years. Okay. Another person who's one of the founders was a physician, a rich physician who was physician for the governor of Jamaica, because this is, put this in proper perspective. This was the sugar plantation and the slave trade was already in full swing at that time. And Dr. Hans Sloan was married to a rich woman and was the private physician of the governor of Jamaica, and was again as was a interested in varieties of the subjects of collecting botanical specimens as well as fossils from all over the world, and this was some of his work on the voyages of various islands. Okay, because obviously the tropical flora and fauna was totally different than from the temperate zone, and over his lifetime he had managed to collect as many as 70,000 objects, books, manuscripts, drawings, coins, metals, plant specimens. Okay, and he acquired all of this, and over his lifetime, and subsequently, as he was getting older, he managed to sell the collection to what came out to the British Museum later on. Okay, and for he sold it to the king for a sum of 20,000 pounds. Okay, and now again, his legacy is a bit tainted because he was a slave owner in his time. So based on the current viewpoints, his legacy is somewhat stained, so to speak, in this time. But he was a product of his time, obviously. So okay. And the classic work that you may recognize was, I mentioned earlier, Robert Hooke was the experimenter for the Royal Society. And this is, one can say, that this was the start of microscopy. Okay. And Robert Hooke, not much is known about him, as to, but he was the curator of the Royal Society and did the experiments that were outlined by the founders of Royal Society, including Boyle and Wren. And this is one of his earliest microscopes. And the classic work that he's known about is called micrographia. And again, obviously, he was an artist par excellence. And you can just see that as to how he painted the details of a flea. Okay. And the book is absolutely, the illustrations are something to be seen. And you can see that he was the first one to coin the word cell, that came from the monks who lived in cells, type thing. So that was the origin of the concept of biology, that is not visible to naked eye. At the same time, his contemporary was a Dutch draper named Anton Leeuwenhoek. Okay, and this again just shows the continental involvement of Royal Society, that he was not an English speaker, not a native English speaker. He wrote in what came to be known as a Low Dutch. Okay, and then he was encouraged by a physician friend, okay, to send his work that he had on his own. He had developed a microscope. You can see his microscope on the right side was a rather small instrument where the specimen was placed lower down, and just by turning the screw, he was able to magnify. But he was a lens grinder par excellence, and his magnification was almost 250 times. So he was able to view details which were far outdid what Robert Hooke did. And he had sent as many as 2,000 letters to the Royal Society. And to their credit, obviously they had published, including looking at his own red blood cells, looking at his own spermatozoa as to how they were motile, looking at the extract from his own teeth, and showed what he called animalcules and letters on protozoa. So this was one of the foundings of something called a microbiology. So one can rightly quote him as, as the founder. So these were the two people who put biology, on the forefront, and again, so this was one of the starts of the biological sciences, Okay. Now, obviously, even if Royal Society had stopped functioning after Isaac Newton, we would still be remembering them and respecting the work that they did. Okay, and obviously, one can talk for a whole hour on Isaac Newton alone, but at least we'll just try to cover some of the basic work. Okay, and all of you know how he was the founder of optics. Okay, of the sending light through the prism and seeing the visible spectrum of colors thing. And along with that, obviously Kepler was his predecessor, and the astronomers for Royal Society were trying to figure out the orbits that were defined by Kepler. And at the same time, Newton lived, a considerable distance for that time in Cambridge. Okay, so Royal Society was interested in explaining the orbits that were defined by Kepler, and the observation for various comets and the orbits were difficult to fathom as to what happened. So one of the founders, who we will talk about, guy named Edmund Halley, was sent to Cambridge to travel to Cambridge to talk to a mathematician who was in residence at Cambridge at Trinity College, Isaac Newton. And Newton said, okay, I had already figured that out, And he asked, where is the proof? Oh, it's somewhere in the drawer. Okay. And finally, after Halley's prodding, Newton published a paper, and that was published explaining the elliptical orbit that was based on mathematical formula type thing. And later on, he expanded into the work called Principia Mathematica, and that was the starting of astronomy and combination of astronomy and mathematics. So one can say that this was the mechanical universe, and so this went against the church doctrine as to the universe operated on a mathematical basis, so to speak. And this tome that he published, was deliberately very difficult and a very hard book to read. Okay, but that was a true incorporation of the predominance of mathematics in explaining how the universe and gravity worked. Okay, and let's see. And this is the classic principle, the Newton's three laws, that obviously all of you studied in your schooling days. The force equals to mass of the two objects, the radius, and the gravitational constant. Okay, so again, but we are not going for physics 101. And Newton was a giant in his own days. One could say that the short, and even the poets alone, a poet of that time, which you may recall from your high school English, Alexander Pope. This was his quote: "Nature and nature's law lay hid in the night. God said, let Newton be, and all was right." Okay, so this was, again, a tribute. So Newton's influence was vast and wide, and this was one of his works, Philosophy Principia Mathematica. This was his another classic work on optics. Okay, so these were the two. Now, at the same time, when we can say that we associate Newton with the classical Newtonian laws and optics, but in his heart, he was a product of his time. He was an alchemist. Okay, he's okay. When his papers were bought, by the Economist in 1936, a lot of his papers included, Maynard Smith. At that time, he bought his trunks of his papers and looked at it. A lot of his work was involved converting, base lead into gold and even his on the more recent analysis of his hair was done. It had high levels of mercury. No wonder he was a little bit bonkers at that time, so to speak. Okay, so again, and at the same time, one has to say that it was eccentric to the thing that at one time he inserted sort of what they call a bot pin, through his orbit to see just what happens from the corner of his orbit. He pushed it all the way inside. Luckily for him, he did not go blind. Okay, So it's just, as to how science can be a risky business, when you get down to it, so to speak. So he was eccentric to his own six. And later on, he moved to London and he was the head of the Royal Mint. And again, he was not an easiest person to get along with personality-wise. He had an argument with Hooke and managed to get rid of Hooke as a experimenter and brought his own person. Okay, so now these are some of the inventions that we talked about: laws of motion, gravitation, and he had a huge ongoing fight with Leibniz from the continents about of who was the first to discover calculus. Okay, and they were both contemporaries, and probably the discoveries were simultaneous: reflecting telescopes, Newton's ring, binomial theorem, and so again, his impact, is vast, and we can spend almost an hour talking about each of this, so to speak, and again, he had a different assistant that we talked about. The name is Descoureris. It's a French name, I think. Okay, and oops, excuse me, escape. Yeah, that works better. Yeah, this was his assistant, who French exile, Huguenot. Okay, and he was the assistant who did a lot of his works type of thing, experimenter. And again, this right from the beginning, way before Nobel Prize, Rich, who had donated some funds, which was the start of the Copley Medal. And again, that is still very much into existence. And these were some of the earliest works that he was awarded for doing the experimental work on varieties of fields. Okay, and see, these were some of the fields that they were interested in at that time. Okay, again, astronomy was very much a subject of curiosity at that time, and the person that about, Edmund Halley, Halley's Comet. And again, these were all people who were independently wealthy and, were able to fund a lot of their own research. And he was the one who traveled to Cambridge to talk to Newton to get the proof of Kepler's laws. Okay, and the very first astronomer royal was a guy named Flamsteed, and Halley was his assistant. And based on Flamsteed's chart, he had made the catalog of all the stars in northern hemisphere. Okay, and then subsequently, with his own fund, he had traveled to St. Helena Island to map the stars of the southern hemisphere. Okay, and again, he had, based on, he had traced the orbit of varieties of comets. And now the Halley's Comet, which we've all heard of, he was not the first one to visualize, okay, because that was mentioned in the Arabic literature, Asian literature, for long before Halley, okay. But Halley's name came to be associated with him, several years after he had died, okay. Now, we mentioned earlier about the publication of Principia Mathematica, and Halley, the Royal Society did not have enough funding, so Halley paid out of his own pockets to publish the great work of Isaac Newton. Okay, and again, the book did not sell very well and earlier, so Halley was left with footing the bills for this thing. So this was the orbit as to Halley's Comet appears every 84 years. I think so. This is a pictogram of how the comet just makes turn and disappears, and it is associated with a lot of the false belief as to the age of doom. When it appears, something bad is likely to happen. So a lot of myths are there in varieties of cultures. Okay. Now, interestingly, obviously, the Britain was a naval empire at that time, and when the ships were traveling around the world, they were running aground, were running into rocks and bad weather. So determining latitude was relatively easy at that time. but they had a severe problem determining longitude. Now, during Flamsteed era, Greenwich Observatory was defined as the Greenwich was considered center of longitude, and the problem was so acute that that the king had appointed what came to be known as longitude board, okay, which included varieties of astronomers and scholars of at that time to solve so-called as the longitude problem. And the problem was so acute that they had promised a prize of £20,000. So one can see, considering the purchasing power, it's a staggering volume. But this was a varieties of important problem, and there were varieties of method that were being proposed to determine longitude. And the method that was based on the second astronomer royal, a guy named Neville Maskelyne, was based on stars and lunar charts. And it was various mathematical calculations, though he was a proponent of this. At the same time, this is, you may be familiar with a commoner named John Harrison, was a master watchmaker, okay? And, and he had made variety, because the problem that comes with any clock which is based on pendulum is that when the clock travels on the ship, the motion of the ship, throws off the pendular motion, and the clock loses its accuracy. So Mr. Harrison had worked on what came to be known as Harrison's clock, and his models were submitted to the longitude board and were put aboard ship, initially across the channel and then across a trip to Jamaica. And some of his models were remarkably accurate. So he worked on patiently on improving the model for as many as 19 years. And it was followed later on by his son. And the varieties of H1 and H2 models that Mr. Harrison had created, one can still go, because when I went to the Greenwich Observatory, these are still on display. And these are some masterpiece of work as to how the varieties of pendulum, you can just see as to how the craftsmanship is exquisite. And then initially, this is the last, is the upper right-hand corner, is the last model as to how compact and elegant design it was. And this has been well summarized in a book that some of you may have read about by Dawa Sobel as to on longitude problem. And again, still even after this, his clock was accurate to less than 2 minutes, for a longitude determination, okay, with the local time. But still the longitude board with the scheming of Neville Maskelyne, balked at paying Mr. Harrison, and eventually he did get some award, but not quite what it was promised. Okay, I think we're coming up to 11 o'clock. We should probably pause for about 5 minutes and continue my monologue or soliloquy. I think we're running probably reasonably on time. So, and if I don't finish the material today, I'll just send out the slides later on. So let's meet back again at 11:05. I will pause the recording and get a sip of water and share screen. Okay, this time I remembered. So, okay, all right. We should have the slide for you type of thing, hopefully. Okay, yeah, let me move this here, this side. Okay, we got it now. All right, okay, now I can see all of you. And so we'll continue with this, I think. So now, again, this was, as you can see, that the first class, this was a politically incorrect slide. It all talked about males, but there was one woman who was an exception type of thing, which I figured, that not to get all the women in the class and OLLI mad at me, Mary Somerville. She was the, queen of science, so to speak, and there is a college named after her in Oxford, okay, Somerville College, and, and she was, a woman who had written, she was married to a person who was more supportive of her, and then, on her own, she had studied enough mathematics and had written, translated works of Laplace, and it had submitted papers to Philosophical Transactions, of of mathematics on ultraviolet components of electromagnetic spectrum, okay, and various papers, type that she had submitted. And so she was a force to be reckoned with, and she was one of the first one who had written a book called Connections, and that incorporated what has come to be known as interdisciplinary work, so you can just see that this is a book way ahead of its time, okay, type thing. So I mean, obviously, I'm not going to translate the Roman this thing, so, but it was written probably, in the, uh, uh, early 19th century, I think so. And it's written varieties of other works on astronomy and incorporating various sciences. And she was one of the first ones who was supportive of women's education and vote suppression, because obviously the Royal Society was fairly conservative. And guess it took them till 1945 to induct a woman as a fellow type of thing. So, okay. And so it was, really, they took their own sweet time to allow, one of the women and back in 1903 had applied, but the lawyers for the Royal Society had argued successfully that no, women cannot be a member of or fellows of the Royal Society type of thing. So she was outvoted. So it took until Dorothy Hodgkin, which at least the biochemist amongst you know who she was, and we'll talk about it, in the next few sessions, Okay, so there was Mary Somerville. Now, another person who is equally instrumental, or the so-called associated with the Royal Society, is none other than Joseph Banks, okay, and after Isaac Newton, who had a huge impact as a president of Royal Society. And you can see that Joseph Banks was, obviously, he was independently wealthy, a naturalist, and he had, at young age of 23, he had funded his own trip on HMS Endeavour, which was sent to the Pacific to the transit of Venus. That was the big thing that was that the Royal Society had funded, had undertaken, and that was the Captain Cook's trip. And so he was the naturalist who had accompanied James Cook. Okay, and the trip was, obviously, the amount of risk that they took was because, obviously, he had his whole entourage. He had an astronomer with him. So he had about 3 or 4 servants, and per his attendees. So he had a staff of about 10 people that he had funded on his own. Okay, on HMS Endeavour, and obviously, and out of which several of them had died. So it was a hazardous journey. And obviously, it was at a risk to his own life. He had joined and went to Tahiti and had collected the specimens in the New World, which was Australia and New Zealand, that they traveled to, and obviously, and along with the astronomers, they had plotted the transit of Venus over there, and this were. And it's a fascinating story, the transit of Venus, that was sponsored by varieties of European nations all across the world. Okay, and the transit of Venus occurs, it takes almost like every a couple of 100 years, and with a span of 8 years separated. So it was scheduled to be, was predicted to occur in 1761 and 1769. Okay, so the varieties of countries had sent out missions all around the world, including to Antarctica, to India, to South America, to United States, okay, and to various islands, to St. Helena Island, Cape of Good Hope, okay, and in 1769, and some of them, obviously, it's a fascinating story in itself, which we'll get to as we go along, type of thing. Okay, I think I might have missed a slide, type of thing. Let me see if I did. Okay, yeah, I think it should be coming up, hopefully. So Joseph Banks, we were talking about, type of thing. So it was a 16-month trip, and obviously, Tahiti was a word which was totally alien to Europeans, because obviously it was the people were friendly, and women were even more friendly, and there was nothing like personal property. The idea that was totally alien to Europeans, type of thing. And and it was it was almost like they had entered the hippie version of that era, so to speak. The sex and relationship were friendly, okay, and obviously and they did not have they were not into the European weapons, and the Captain James Cook was a strong disciplinarian and established quote unquote fort, and there were some tussles with the native, but overall the relationship were very friendly, and they successfully mapped the transit of Venus. Now Joseph Banks was one of the few persons from the ship's crew who managed to learn the Tahiti language, and was sort of a person to go to, was trusted by the locals, and on his own, when some of his associates were traveling into the further deep in the island, he had managed to save some of them, and had quote unquote gone native, so to speak. And later on, obviously, so being a young person, it was the free sex and friendly relationship with the local ladies was a total alien to the concept type thing. And they had managed to return several native plants, okay. And then after returning, obviously, not everybody came back from the trip that was made, and Cook and Banks were became heroes return. And after that, during the second expedition, he had again made an appeal to the Royal to the Navy that he would travel, but obviously his offer was turned down because he was asking for a lot more facilities. And this was the earlier search for varieties of plants that were brought to tropics. And later on, he was instrumental, and he was involved with the Royal Society. He had published a lot of his own works, and was instrumental in sending specimens to what was Kew Garden at that time. And obviously, it ended up being the headquarters for the botanical collections for the empire. And he remained as a Royal Society president for almost 40 years. So there was usually the term is for 5 years, but so Joseph Banks was very instrumental in the early days of Royal Society type of thing. So he continued, and then obviously later on, and this were some of the paintings that were done for because all these animals from the Australian era were, and during one of the trips, the Cook had managed to bring a Tahitian native called Omai, who was brought to England, and he again, he was even given audience with the king, and okay, so there was enough cultural exchange that was going on. Now at the same time, this was like we were talking at the break time. This was an era that people were genuinely interested in exploring the world, not just for profit, but just for curiosity and finding out what that nature's secret, so to speak. And enterprising Scotsman, named Mungo Park, because obviously this was like the starting of, even though people knew about Australia and other parts and the Americas, Africa still remained a dark continent. And this was the era where Mungo Park, volunteered to go to Africa and explore the route of the Niger River as to whether it was flowing east or west. Okay, and again, so he had made 2 separate trips, later on sponsored by Royal Society and Joseph Banks, and again, so this was now obviously it was a dark continent to the Europeans, but it was not dark continent to the sub-Saharan Arabs, okay, type thing. So he had some difficult encounters with the Muslims, and his was robbed and taken prisoner, managed to escape, and during the second trip, I think he was killed second time, okay, and one of his colleagues did manage to come back, and so this was, and now again, obviously this was originally it was done for exploration, but during the second trip that was a clear-cut agenda that the government had said, well, how suitable it is for settlement and colonial. So there was, obviously politics and science and exploration went hand in hand. Okay, so this was the legacy as to how he'd taken some. You can just see from this diagram as to the varieties of trips that he had taken, and those were, and then obviously a lot of people died of malaria and dysentery because obviously they did not have any resistance. Okay, yeah. And now again we talked about energy, and this was the so-called rise of industrial revolution that took place in Britain. Now again, when you look at it, why it was, because the coal was easily accessible, was close to the surface. Okay, and the area where the coal mines were relatively flat, so it was easy to build canals. Okay, so this was the start of the industrial revolution. And James Watt again, was a self-taught, man, and he based his work on a so-called Newcomen engine, which was there too, because the problem with the mines was that they got flooded with water. So this was the idea of using a steam engine to pump the water out, and so that the miners would not drown. So this was, and
Can't hear, Brett.
oh, I'm sorry. Oh,
The engine was preserved from 1898 by the Canal Company.
can you hear it now?
Yeah, that's got it.
Hill. And when that depot closed, it was moved to the Old Science Museum before moving to think tank, the Birmingham Science Museum at Millennium Point. James Watt was an instrument maker at Glasgow University when he was asked to repair a model Newcomen engine. And he managed to get it going, but he also realised how chronically inefficient it was. Many other engineers have realised that, but he began to study it scientifically. But James Watt realised that the problem was that within the Newcomen engine, the earlier design, the steam and the condensate remained in contact, and a lot of problems, thermodynamic problems, which weren't understood till later, came from that. He developed a separate condenser, where after going into the steam cylinder, the steam could move into the condenser, which was cold, and produce the vacuum needed to operate the engine. While journeying to London to take up a patent for this improvement of the steam engine, he called in Birmingham, where he met William Small, Matthew Bolton, and the Lunar Society, and he realised it was quite an interesting group of people. A little later, when his businesses in Scotland were badly affected by the failure of the banks, he took up Matthew Bolton, the Birmingham businessman's offer to move to Birmingham and perfect his engine design. James Watt carried out some tests on this engine in 1779 to establish his new method of working the pumping engine to make them even more efficient. The engine worked for 112 years, and for most of that time it was lifting 1,500 buckets of water every minute, and that allowed 250 boats to proceed along the canal between Birmingham and Black Country. The engine is important to it, not only because it's the oldest working engine in the world and one that James Watt worked on, it is also one of those engines which maintained its original layout and its original operating arrangements. It even has the original timber beam, dating from 1779, a massive piece of oak. this is its first run since a major refurbishment. All sorts of little things have been dealt with, but the main problem was that the main pump, the one that lifts a ton of water every minute.
Okay, so you get the idea type of thing. So, and there is one that's still in the United States, you can see it at the Ford Museum in Detroit, Dearborn Ford Museum. Okay, so if you are traveling in the Midwest, you may be able to see it. And this was the idea came, is to see how accidents came, because he got the idea from watching a tea kettle boil. Okay, and again, this goes around as to how competition goes around, because Newcomen was a blacksmith, and whose ideas were based on other people, a guy named Thomas Savery, who had worked on it, and another French Jesuit physicist named Denis Pepin. Okay, so he had devised on the side. He had devised what we know as pressure cooker. Okay, type thing. So this was, and again, he was encouraged by Joseph Banks to cooperate and the Royal Society people to work with Newcomen. But again, so they were never shared the patent money type of thing. So the tussle between the French and the Brits continued. Now, as to why this occurred more in Britain and not anywhere else, I already elucidated that, because this was the manufacturing was close to the coal. It was easily available. And again, for whatever reasons, the wages in Britain were higher than that on the continents. And obviously, by this time they had enough colonies, so they had a captured market. So that was one of the okay. Now, again, falling back to the medicine aspect of it, the person who was another self-taught scientist and scholar was James Hunter, that we talked about when we did the history of medicine, because the dissection was considered taboo at that time. So they were literally body snatchers. Okay, and he was a master anatomist, perfected the art of surgery based on real anatomy. And the famous skeleton that they borrowed against the patient wishes was the so-called Irish giant, who did not want to be dissected, but they paid 50 pounds and borrowed his skeleton. So this is still available at Hunterian Museum. That was closed for repair for a while, but it may reopen, I think probably next year or something. And this was one of his surgical things. He took out this parotid tumor, because obviously the surgery was very hazardous in those days, but he was able to successfully dissect out the tumor. Again, this was before anesthesia. Okay, so this was the start of the surgery type of thing. Okay, and then again, the paper that was published in, this is, I just made this slide yesterday, vaccination then and now. Okay, and this is, the paper. You can see that Edward Jenner's paper, and the causes and effect of variola vaccine from Gloucestershire, cowpox vaccine. Okay, and the story is well known, that all of you studied in school. And the idea was borrowed from the Ottoman Empire. Okay, a lady named Lady Montagu was traveling, and she had learned the vaccination process that was prevalent in the Islamic culture. And the difference that was that Jenner did what one can say it was the first controlled trial. Okay, that he not only vaccinated the young boy, but again reinfected him with smallpox. Okay, now initially, to their credit, this is again, this applies to this thing, that just because you take vaccination for COVID does not mean you'll not get COVID. Okay, so that was the objection that Royal Society had, that obviously, cowpox prevented smallpox, but smallpox did not prevent cowpox. Okay, so again, Jenner did a very controlled experiment. So eventually his, on about 20 patients type of thing. And so he actually, he repeated his experiment and proved that yes, indeed, the vaccination was effective in preventing, smallpox. So this was the trial. So this was, and it was universally very quickly accepted. It was accepted by Jefferson in Americas, okay, and was accepted all over the continent. Napoleon accepted the idea that war or no war, he awarded, the Jenner, and he gave prize to Edward Jenner. It spread all the way across the Japan. The Spanish Empire carried out a mission to vaccinate all their colonies and empire. So it was widely accepted without any controversy. At the same time, this was a paper that was Science and Trust. This was a talk that is done by a Bengali woman with an unusual name, Sheila Jassoff. She's a professor in linguistics at Harvard, and this was one of her talks as to what is in. This was just done last year during COVID. As to this illustrates 3 countries, Taiwan, Germany, and United States, as to how the vaccine was received or not received. So this is a slide that you can peruse type of thing as to how it has a cash relief. And the United States, obviously we failed into getting a wide acceptance to the COVID. So this was how different approach to vaccination was in 3 different countries. So this was part of his talk as to how people are losing trust in science, and as to how the politics of the nation state has a huge impact as to how people would react. And so this is, again, as we talked about, this is an era of eccentric, self-taught, brilliant people. And the 2 that need to be mentioned are Henry Cavendish. And Cavendish was independently wealthy, okay, and was shy to the point of default, so to speak, avoided even talking to his own staff, okay, had independently established his lab and had carried out experiments on chemical experiments and proving the existence of hydrogen and oxygen, splitting water. And you can just see how the formula, which is zinc plus sulfuric acid, detection of hydrogen, okay, thing. And obviously the discovery of hydrogen, which was carried out by Cavendish, and at the same time was carried out in France, led to what came to be known as balloon mania, okay. And that was the big rush that came on about man's ability to fly, type of thing. And again, so varieties of experiments were carried out by him. And okay, so at the same time they were interested in electricity as well, okay. And the other person who was a contemporary of that time, was proving was Joseph Priestley. Again, he was established the presence of oxygen. Okay? And Joseph Priestley was a Republican supporter of French Revolution, and obviously that did not go very well. And he had to exile himself out of Britain and ended up in Pennsylvania. Okay, so this was the earlier way of founding of the gases and the finding of what came to be known as formal chemistry. Okay. Okay, and again, so I put both of these people for the sake of slides, on the same this thing. So Cavendish worked, in varieties of fields, including chemistry, physics, electricity, magnetism, and again, he was on his own. He had done experiments on weighing the weight of Earth, had calculated 2 huge balls suspended on a fine silk rope thread, and managed to do observation on gravitational pull of this balls, and based on that, he had managed to calculate how much did Earth weigh. Okay, so varieties of experiments were carried out to determine the age of the Earth, as well as the weight of the Earth, radius of the Earth. So a lot of this was curiosity-driven science, because obviously it did not have a whole lot of economic value at that time. Moving on to the other part, it's like obviously all of us associate electricity with Ben Franklin, but predecessors of them were guys named Stephen Gray. So this is several decades before Franklin, as to how the initial days, obviously from the Greek era, people were aware of electricity by rubbing the amber rod with wool and generating spark and getting electrical shock. So that concept was known, and this was taken up by people who were sort of street hustlers or demonstrators, and they called themselves electricians. Okay, and again, a guy named Stephen Gray, he was an English dyer and amateur astronomer, was ended up in the poorhouse because he was unable to pay his own debts, as it was the practice was in that time. So again, he had done varieties of so-called show and tell, like the magician type of role of a boy suspended on silk thread, okay, and with the electrical ball with generating electricity and creating sparks type of thing. Okay, so this was like a more of a amusement type of experiments that were done on electricity. And on the other side, we talked about, the Leyden jar was invented based on lead battery in Holland, and it was a condenser jar where the electricity was, and it was named after the city of Leiden in Holland. Okay, and so this was, earlier starting of electricity experiments that were done. Okay, and it became very popular all over the world very quickly as to how, based on putting more copper disk, electricity was generated. Okay, and but the starting, obviously all of you know that the well-known this thing was Ben Franklin, whether. Oh, sorry, there should be some more pictures. Now, obviously, some of his experiments that were done as to whether he actually did the kite experiment, that or not, that's still, kind of up in the air, so to speak, Okay, the experiment was repeated, in a French village, Okay, I'm sorry, I have to get down to my notes here. Okay, it's a French name. The most famous experiment that was published in the Philosophical Transaction in 1753 that secured his reputation, and again, he was a printer and an accountant, so that's where he came up with the idea of positive and negative as a balance sheet, so to speak, Okay, and so this was, putting electricity on a more, because originally the people who did research on the continent thought of electricity as fluid, okay, but the Franklin came up with the concept of positive and negative, based on his own understanding of accountancy, so to speak. And some of his experiments were done in a small village in France, okay, and so this is the site where, a wine bottle jar was placed and waiting for the right time where, lighting would strike, okay, and you can just see how at the birth of electricity, okay, and it stuck, and obviously the electrical charge was carried out across, after the lightning struck. So the experiment was repeated in a small village outside Paris, okay, Marly-la-Ville. It was repeated by two Frenchmen where they put the electrical rod in 1752. Okay, so approved as to how the jar held in glass insulator. So the Franklin experiment was. Now, for those of you who are more interested in looking up, he's a British physicist who is does a lot of science talk. A guy named Jim Al-Khalali. Okay, I think he's Egyptian or Lebanese. So he has done varieties of talks on Genius of Britain, history of electricity, and he has a channel called Spark. So he does varieties of talks on history of atomic physics as well as quantum physics. So, a very erudite science teacher. Okay, similar to what Michio Kaku does in the United States. Okay, now an interesting, colorful character that you may or may not have known about with his given name was Benjamin, I'm sorry for the typo, Thompson. Okay, he was a royalist, from Boston. He had married a widow and had acquired some money. And being a loyalist in the U.S. war, he had to run away to the continent and ended up in Britain. And then, he was sort of a true polymath, so to speak. He worked for the King of Prussia. He was a scientist, experimenter, inventor, engineer. He had revolutionized the fireplace design. Okay, so he was a man of many seasons and many talents. And later on was knighted by the German state. I think it was Prussia. Okay, and it was given a title of Count Rumford. Okay, now later on when he came back to Britain, okay, he had founded. He's one of the, obviously being independently wealthy, he had funded what came to be known as the Royal Institution, and Royal Institution was a institution that was formed for popularization of science in general population. And this is one of the satiric, and this was, and luckily for them, the people who were associated with the Royal Institution were a very excellent communicator of science, including Sir Humphrey Davy, who was the founder of chemistry, and Michael Faraday. And so this is one of the cartoons that were published as to how, Sir Humphrey Davy, behind, is making the bell jar, and the smelling of the nitrous oxide, and all the people, he was obviously like a rock star. He was an attractive young man, and all the ladies of the era, were in awe of his talks, and his talks were well attended by the who is who of the era, and including the cartoon that is drawn up was of Sir Joseph Banks in the corner, right here. Okay, and as to how people were making themselves silly, and literally they were getting high on nitrous oxide. Okay, so this was one of the cartoons, and from the early days of what came to be known as the Royal Institution. And this is the website for Royal Institution. This is their building, and you can see probably from the site here, Royal Institution of Great Britain. Okay, and this is the site of the photograph of Michael Faraday showing experiments. We'll talk about Michael Faraday as we move along. Okay. I'm sorry, anything in the chat? Yeah, thank you, Kevin. Okay, all right. And so I said, yeah, that I had the slide for transit of Venus type thing. And this was, the big mission that I already talked about. The transit occurs every 243 years with a big break of between 120 to 105 years. And the varieties of missions that were sent down, including that of Cook that we mentioned. But the one that you may be interested in was two astronomers, who the name may be familiar to you, named Mason and Dixon. And later on, after this thing, their collaboration, became famous. They came to United States and decided the boundary between Pennsylvania and Maryland, the so-called Mason-Dixon line. Okay. All right. Now, moving right along, are the two, again, what is fascinating as to how the continental migration took place, the one German, who had moved to Britain, during the war, after, to probably avoid being drafted or something in the army to Britain, and had worked as a musician, okay, and as a self-taught man, as an astronomer, was William Herschel, okay, and again, this is, and he was working on his own, was grinding his own lenses, okay, and at night, and had nothing to do with the Royal Society, but one of the members' son was traveling through the era, and he requested, can he see through his telescope? And he saw the telescope that the resolution and the details that he was able to see was par excellence. So he communicated that this strange foreigner who is astronomer par excellence. So then he was invited to talk and submit papers to the Royal Society, and the rest is history. On his own, William Herschel, had managed to discover 850 double stars, as many as 2,500 nebulae, origin of stars. So he had idea, and he was prolific writer of his own, and had worked for several decades. Now, again, as we talked about earlier in science, it helps to have royal support. So Sir Joseph Banks, who was the president of the Royal Society took Herschel under his own, his support, and had managed to get funding from the king to sponsor various telescopes, and was given grant of as much as £4,000 to build telescopes. Okay, and obviously, it was artist par excellence, and was assisted by a tiny sister named Caroline Herschel. The brother and sister lived together, and when he would be inspecting through the night sky, and Caroline would be making notes, and the collaboration was tremendously successful. Okay, and later on, obviously, so he was, as we talked about earlier, he was born in Hanover, Germany. Okay, and at the same time, then, so his sister was remarkably astronomer on her own rights, and the next slide we'll talk more about it. Okay, and obviously, so this was in the city of Bath. Okay, and the first large telescope that he built was in 1774. Okay, and worked for several decades on that. Okay, and so, and again, some of his stars that were put in something came to be known as, if you know anything about astronomy, something called the Messier catalog. Okay, type of thing. So, and so this is, and on his own, he had spotted an unusual object that came into observation. And again, he made meticulous observation on 2 or 3 nights, and reported the finding to Astronomer Royal Neville Maskelyne. And obviously, in science, there is no prize for being second. Okay, so quickly he was encouraged to publish, so that so the crafty French would not steal the glory. Okay, and so this was, and it turned out to be, initially he wanted to name this object as like a name after King George, but eventually, the Greek name Uranus was agreed upon. Okay, and obviously the discovery was confirmed by the French very quickly, and so this was, the discovery of the new planet by William Herschel. Okay, and this is again, you can just see this, this is again a basic thing as to how the Uranus was, was a small object. And obviously, some people had questions, oh, he had just discovered it accidentally, but he stood his ground that nope, it was a legit observation. He had spotted the object, reconfirmed it was no accident, type of thing he saw. Okay, and again, from lens grinder to astronomer, and this is his tiny sister in the painting, as you can see how she was. And these were, some giant telescopes. This were like it built. This was his earlier telescopes. About 6.5 inches. Again, and compared to these were the 2 types of telescopes. For those of you who don't have own telescopes, reflector and refractor. So his telescope was different than the so-called Newtonian telescope. Okay, and so he had a far better resolution than Sir Isaac could get. And subsequently, the projects got bigger and bigger, and this was later on. King George had funded him to build. This is what came to be known as a 40-foot telescope. Okay, you can see this was, and he almost, the construction where it employed several workmen to work on it, and this was like a tourist attraction in the city of Bath. Okay, escape, and this is his famous sister, who was, astronomer on her own right. And after, at a later age, when Herschel decided to get married, the sister moved away and decided to observe on her own with her smaller telescope, which was easier to maneuver. And she was, supported by Neville Maskelyne, and on her own, she was, again, this is unusual for her times. She managed to publish in the Royal Society, again, on her own, several objects that she had spotted in the various nebulae, and so, and again, this was one of the, like obviously, the scatological humor, as to you can see how the bad smell of sulfur from the stars, so to speak. You can see how the comics were not about making fun of astronomers at that time. Okay, moving on to the other person, again, self-taught, Calvinist, very unassuming person, John Dalton. He was, working on his own and on chemistry. He was one of the first scientific proposition of atomic theory to explain the properties of various elements, depending upon different weight and different chemical properties. Okay. And again, you can just see that the axioms that he proposed, are very, very, very valid. Obviously, that we have succeeded in splitting the atom. But again, the logic for that time was the John Dalton's atomic theory. And again, it was a very unassuming person that he was offered, membership for Royal Society, but it turned down. Okay. And the story that Bill Bryson tells, and he managed to teach arithmetic to young children. And when one of the Germans wants to visit him, okay, let me put this little kid to correct in terms of on his arithmetic. So quite an unassuming Calvinistic person. And as talked about earlier, was and again, very popular, in his own days, and was highly respected scientist, totally self-taught person. Another equally self-taught person was Humphrey Davy, who was from Wales and had a good mentor, okay, and who had managed to be an apprentice to a physician, and again was interested in self-taught chemist, okay. And after his apprenticeship was over, he by this time the Leyden jars and electrolysis was available, and had later on just happened to be at the right place at the right time, had moved to the Royal Institution and was appointed as a chemist to the Royal Institution. Okay, and it did very popular speaker, as we talked about, as you can see that at the young age of 23, he was a very erudite researcher, scientist under the auspices of newly founded Royal Institution, and later on became professor of chemistry. And the elements that he discovered, based on with electricity, were all the inorganic chemistry, the elements that discovered: potassium, sodium, barium, calcium, magnesium, strontium, boron. Okay, and just for a side measure, as we talked about, that the mining industry was, dealing with the problem of explosions due to gas methane in mines. And so Humphrey Davy, just with intense research with he and his able assistant, which we'll talk about a little later on, Faraday, had made, the Humphrey Davy lamp to detect the presence of a methane gas before the explosion took place, so that the lives could be saved. And the mine owners were obviously very grateful to Humphrey Davy, and then again, the Leyden jars that were imported from the continent, he had managed to build one of the largest batteries of that time in 1808, 800 piles of lead plate and carbon filament, and that was the start of what came to be known as arc lamp, Humphrey Davy arc lamp, and the brightest spark that he was demonstrated. Okay, so again, this is what fascinates me as to how these people were all self-taught. Okay, the second, that he was his able assistant, he was also a self-taught man. Okay, he was working with printers and had managed to read Encyclopedia Britannica and a book of chemistry on his own. Okay, and later on he had attended lectures of Humphrey Davy and took notes of the lectures of Davy, okay, and managed to give the book of 300-page book that he had written him on his own to Davy as a gift. And obviously that was enough to impress Davy, and he was hired as an assistant. and as a lab assistant, and from that gradually moved on to doing experiments and becoming and coming into his own, coming into his own. And these are some of the things that he discovered. And you can just see this is the illustrious man himself. This was one of the experiments with this thing as to how the rotating this thing and electricity, the discovery of electromagnetism. Okay. Okay, let me just go down to the next one. It was the ball of mercury, copper rod, magnet rotating, and so this was the rotating force and generating of first formation of what came to known as basically electricity. Okay, other invention, refrigeration, freezing of ammonia as a liquid, electromagnetism. Okay, something called diamagnetism, as to how every element had a small magnetic field around its own, and it's the Faraday's laws of equations. So, and again, if you're inside a metal cage, you're insulated. Okay, and so this was something called Faraday cage. So this was, again, you can just see that the foundation of electromagnetism. And again, on his own, he had proposed, something called the magneto-optic effect. So light bends due to magnetism. So varieties of this thing, that what we own is the foundation of electricity is a practical use. We owe it to Michael Faraday. Okay, and this is a long video of electrical energy and Faraday's. I mean, this is a YouTube. I will send out as a link because I don't think we'll have time to show that. This is a long link. I think this goes on for like several minutes. So from the Royal Institution. So I don't think we'll play this right now because we just won't have enough time to go through that. Okay, I think we're. Okay, now again, the breadth of Royal Society was just phenomenal type of thing. There's not a single field that did not dabble into or investigate. We talked about chemistry, electricity, magnetism, astronomy, and again, geology was coming into its own. And the two founders of geology were a guy named Hutton and Lyell. Okay, and again, obviously, this was going against the biblical thinking that was in vogue, that the earth was relatively new and was formed 6,000 years ago, as it said, in the holy books type of thing. And based on the observation of the rocks, again, the breadth of these people, Hutton's was a physician, decided to become a lawyer, then was interested in rocks and geology, and on his own had written a tome of the history of the earth. Okay, and the book was really hard to read, so to speak, and difficult. And this was his idea for formation of earth, as to how the gradual development of erosion took place, and the heat from the center of the earth transmitted, uplifted the rock, caused erosion, and then gradual transport and layers deposition. By observation of the rocks in Scotland, he had formed the basic principles of geology, as to how the earth was very old, and went against the so-called biblical thinking. The changes were slow, and the controversy in geology that was going on between what was said to be Neptunist versus Platonist. Okay, so as to how the rock formation took place. So this was the founding of the Earth's heat provided the energy to do the uplifting of the rocks. Everything. So this was this foundation of geological science as we came to know it. And there were heated arguments. And again, the most of the geological thinking was done in Britain. That's why a lot of the geological names are British names, Devonian, the eras and stratas that you had to memorize when you took a geology class, Silurian, Devonian, and all the epochs and eras that are well known in geology. They're all, a lot of them are British names. And again, that gets to be very confusing because the American names are a bit different. Okay, and again, the cartoonists were not about always making fun of James Hutton or and now. Okay, I think we probably should stop here, and I'm behind by about 20 slides, but we'll make up for it as we go along. Or if people want to stick around, I can go on for 5 extra minutes or something, so we are not too far behind. Okay, paleontology was coming into the vogue, and the cantankerous paleontologist was founder of the British Museum of Natural History, named Richard Owen, who was jealous of Darwin and not a Darwinian. Okay, and you can just see that he popularized, because before that the museum was left to the so-called scholars, but he was one of the first ones who allowed a general public to visit the museum and learn sciences. Okay, and again, it was not an easy person to get along with, so to speak. And again, by this time, fossils and paleontology was coming into the world. Okay, and so he's the founder of the anatomist par excellence. And again, the controversy goes along with between they thought that the new word fossils were kind of below par, and that did not go well with Jefferson. So he had managed to send him some skeletons and fossils from the Americas. Okay, and at the same time, there were some other amateur astronomers. A young girl who was about 14 or so, named Mary Enning. Okay, he had collected fossils on her own on the Devonian shore. Okay, type thing, and she may have been the one who is behind the mnemonic. She collects seashells on the seashore. Okay, so she may have been a girl who was behind it. But obviously, women did not get much credit in those days. So there you have it. Okay, so then again, then on the other side, another colorful character named William Buckland, who was a clergyman, but at the same time was a geologist, paleontologist, and was again, big into studying dinosaurs, and give the variety, this thing. And he was big into studying, the poop of the various animals, the coprolite studies. Okay, so there were some colorful characters who were begin to, in the summertime was considered the big way to go ahead and hunt for fossils. So that was the fashion. Okay, and I think we should stop here, because otherwise we'll run out of time, and I still have I'm behind by about 25 slides, but I'll stop here, stick around for next week and share, and we'll continue next week. Okay, but thank you, Mr. Lee, or Professor Lee. I appreciate it. Okay, and I will send out I think I'm behind by about 20 slides, but I think hopefully we'll make up for it next time.
Yeah. Great. Thanks, Brett.
Okay, thank you. Thanks for signing up. And I'll send out the recording. Okay,
Good.
All right, auf Wiedersehen.
Bye-bye.
Okay, I have to attend the class on Science of Aging, given by Gerald Stalk from
Oh, yeah.
from the